afraid, yes, but you're going to have to end up using polynomials.
Yeah, I did it without.
Of degree 3. And I'm not sure you will get real values in the polynomials. I mean, rational numbers. I know one of the solutions would be 1.
Negative.
Is it minus
Negative.
1? Negative 1.
Then the other is like.
And the other would be like decimals.
Yeah.
So it might be complex to do at this stage. So that's why graphs will be allowed. Yeah, something like that. Okay, so I think the easy way is this. Most of you did that. What's the question by you? What?
Log y base x plus 1.
Y base x plus 1 equals 2 and
Log x base y plus 1.
log x base y plus 1 equals 1 over 4. Okay, so there are two equations. From here, this implies y equals x plus 1 squared, correct?
Yep.
Yes?
Yes.
And this implies y plus 1 to the power 1 over 4 equals x. Now this is indices. If I need to get rid of this, the reverse of this is what? Power 4, right? So this implies y plus 1 x to the power 4. Yes? And this implies y equals x to the power 4 minus 1. So now the long approach, I need you to analyze this, give me this. Then however you do it from this point is acceptable. Okay? I think the best way is just to graph this and this. If you want to do it the longer way, you're going to end up saying using simultaneous equation, which is what you're trying to achieve in the graph anyway. You're going to say, oh, this is equation 1, this is equation 2, because y and y are the same. You're going to end up saying x to the power 4 minus 1 must be equal to x plus 1 all squared, isn't it? And that will have been x to the power 4 minus 1 is x squared plus 2x plus 1. And that will have been x to the power 4 minus x squared minus 2x minus 2 equals 0. Okay? But even to get the first factor of this might be a problem. So I wouldn't go through this at all. Sir, are you saying that? Okay. I mean, are you just capturing it for Clarissa? Are you capturing it for Clarissa?
Yeah.
Okay,
Yes,
great.
report.
Okay, so I will go through this route if I need to show at least one of the solutions. From here, x to the power 4 minus 1, x plus 1 squared, I would rather do this. Lillian, I need you to listen to this as well. This is x squared squared, this is 1 squared, correct? And this is just x plus 1 in two places. Yes? So this will be x squared minus 1 and x squared plus 1. I use difference of two squares on this. I can bring this to the other side. Actually, I can leave it as x plus 1 squared. Nobody cares anyways. Okay? Then I can apply difference of two squared again here. Then I get x minus 1 or x plus 1, whichever one comes first. Nobody cares. And this is x squared plus 1 minus x plus 1 all squared equals 0. Now this and this are different. They are never the same. However, there's a common factor. And the common factor is this from this group. And it's the same here. I can bring out the common factor, which is x plus 1. From this group, I have this left. And that is x minus 1, x squared plus 1. Yes? And from the other group, I have one of these left. Yes? So if I now, if the product of two numbers is 0, then either the first is 0 or the second is 0. That's why this would be negative 1. That's one of the solutions. Okay? And this would be a quadratic, an equation, a cubic equation, which is going to be x cubed, blah, blah, blah. Let's simplify it. So this is x plus 1. This is going to be x cubed plus x minus x squared minus 1 minus x minus 1 equals 0, right? And that gives x cubed minus x squared. There is no x term again.
No.
X term is gone.
Yeah.
Yep.
The minus 2. Yes?
Wait, no.
Check if I made a mistake. I'm thinking this is x cubed plus x, then minus x squared minus 1, then minus x minus 1. So this and this goes. Am I right? So definitely all I need to solve now is either x plus 1 is 0 or x cubed minus x squared minus 2 is equal to 0. Okay? And this will give me -1, that's the first solution. And here there are 3 solutions. Maybe they are all real or they are all complex. It's too early for you to go through this for now. But later, after I've taught you different other things, then you'll be able to go further, which is why you'll be allowed to use graph. As a matter of fact, in your curriculum, the new syllabus, I didn't say anything like doing polynomial, like in deep, in depth. Just a minute. Just a minute. So, but let's think, are there factors we can get from here? 1 is not a factor. -1 is not a factor. Because this will always be -1. And we need +1. So you can't get that. So it's definitely going to be a decimal. And that's why we have to graph it. Okay? So if you graph this, you end up getting, if there is any other value of x.
1.7.
All these values of x can now be put into y equals x plus 1 squared. Of course, when you put -1 here, you get y is equal to 0. So the first solution is -1, 0. So the second solution depends on what you get here. I think here, there is only one more value. So which means the cubic equation might be something like this. This is x-axis. This is the reason why you're getting one value. It's meant to have 2 turning points, yes? Parabola, we have 1 turning point, like that. Cubic is meant to have 2 turning points, something like this. But the solution is where it crosses the x-axis. So you might be looking at something that looks like this, where it touches only at 1 point. Do you get my point? Or you might be having something like this, it comes this way, and it never touches again. That's why you only have 1. But there should be 2 turning points. Yeah, something like that. Okay? So wherever they meet is the, but instead of, going through this stress at first, then later graph it, why don't you just grab this and this?
So we have 2 sets. So this is one.
That's the first one. Yeah. Check the intersection. Intersect. I believe this is.
Yeah. These are the answers.
So the first intersect should be, you must get, is it -1? -1, 0, and the second is what?
1.7 and 7.3.
3 significant figures. 1.6 what?
1.69. 1.70.
1.70
And
and
then 7.27.
7.27. So that you have to solve x and y. Using the graph, x is equal to -1, y is equal to 0. X is equal to 1.70, y equals 7.27. That's all you have to do with it. It says solve the equation, that means find x and y. And x and y are the coordinates here. So when x is this, y must be this. When x is this, y must be that. That's the meaning of these 2 coordinates. Does it make sense?
Yeah.
And this, you think you don't understand what I mean yet?
Wait. So
Check the question. What does the question say?
that's on my phone.
Okay, I don't want to. I use my paper. The question says here, solve the system of equation, which means find x and y.
Oh, so it says
X is what? Y is what? Yeah, that's it. And you have to do it for both x and y. So x is this or this, but when x is this, y is this. That is the first solution. When x is this, y is this. That's the second solution. That is what is represented in this coordinate. Okay? You understand now? Any question? At the back, any question? Yes, sir.
If you put the -1 into the log, then the base becomes the negative.
That's x, not y.
I know the x.
Oh,
So x.
she's got a point.
Yeah.
We can't have a negative log anyways. We can't have any, that means the first solution is not even a solution. So this is the only solution. I was saying this to solution based on these equations, not based on the beginning. That's a good one. So you have to be able to make sure it satisfies the equation.
How do you get 7.27?
From the graph.
Wait,
the
if
graph
The
is.
graph is like this.
Well, you're putting the wrong graph. Can you look at what he has done wrong?
Oh, no. Oh, I get it now. For the second one, right? The x cannot be negative.
Yes. Even if, and look at this, even from the first one, x cannot be negative because it means the base is 0. That doesn't make sense. Alright? That doesn't make sense. So this is definitely not a solution. This is the only solution.
So on the exam, what do we do? Just say
So on the exam, once you write this, or you say, but minus 1, 0 cannot be a solution.
no, like how do we talk about
The graph.
do we just write the graph?
Yeah. You can have a sketch of it. You can have a sketch of it. But the graph of it looks like, and this is intersection. Technology is allowed in the exam.
The
Yes.
graph doesn't show the answer.
I don't know why, but it is showing the
Wait,
answer.
amen. I'll show you.
It is showing the answer. You can see the intersect.
No, but like I don't know if it's 7.27 or 7.2.
Just hold on. Just listen to it.
Why do you only have one? Okay, just draw.
Menu.
Intersect. No, go back.
Yeah, sure. Oh. So
Hey, does it make sense? Questions?
Oh.
Is everything okay now?
I look at the rest of the questions.
Yeah, I'll take that. So that's why we are not taking this. So I would recommend you make sure you sketch it. Of course, your calculator gives you what the sketch looks like. Just put a sketch as part of your solution to justify why this is it. It doesn't take long. So this is your x and y. So maybe one is this, and maybe the other is like that. Just put a sketch and label the coordinates. How you got the sketch doesn't matter, because technology is allowed, so we know you've checked in the calculator. But at least put it there so the examiner knows what you're referring to.
The intersect is the intersect of the two lines.
The two, yes. When you're asked to solve this equation, okay? When you're asked to solve the equation, maybe x plus y equals 5, and maybe x minus y equals 1, and you get 1, 2, and 3 are the solution. 2 and 3 are the solution. That's what I thought of to do it. Now, it means the two graphs meet at 2 and 3. So to solve this simultaneous equation is to draw the graph of that. Graph of this will be y equals 5 minus x, which is going to be like this. Graph of this is going to be x minus 1 is equal to y, which is going to go like that. How do I know? Because this is a negative gradient, so it's going to come down. Negative x. Coefficient of, remember y equals mx plus c? M is the gradient. So here m is negative 1. But here, so I'm not doing magic. Don't think I'm doing magic. No. So x minus 1, m here is positive. So this will go this way, the other one will come this way. And both of them meet at 2, 3. So the 2, 3, where is it 2, 3? Or 3, 2? Yeah, x is the bigger one. 3, 2. Because it's 1, not minus 1. So they meet here. So the meaning of your solution when you use the elimination method, you get 2x is equal to 6. The meaning of that in graphically is that is where they intersect. That is the point common to them. There are other points that can give you this. X could be 4, y is 1. Okay? So 4, 1 will be here. X is 4, y is 1. Oh no, X is 4, y is 1 will be here. X could be 5, y is 0. X is 5, y is 0. X will be 0, y is 5, could be here. And on this as well, on the other graph, x minus y is equal to 1. You can have 3, maybe 2, 1. This is 3, 2. You can have 4, 3. So there are points on this graph. But there is a point that is common to both of them, and that is 3, 2. So that is the meaning. So when you find the intersection of two graphs, you are looking for the values of x and y that satisfy the equation simultaneously. Satisfy means make it valid, make sense to both of them.
So that's not there's only one intersection, so the other one.
The other one is invalid. So when you write this, that from your sketch, I will advise you explain from your sketch. You have labeled this to be -1, 0, and you have labeled this to be the decimal number. Then you explain why this one is not valid.
But there's only one.
No, there should be two.
Press the
One is -1, 0.
Okay,
Press
sorry.
the button.
Okay? There should be two.
Yes.
So does everybody understand? So you have to justify why you are eliminating this as a solution. Okay? Even though x and y satisfy these, but x cannot be negative. Okay? Because logarithm of a negative number does not exist. Logarithm of a number, the number has to be positive. Okay? The number has to be positive. Greater than 0. Okay. And even at that, even if x is satisfied, y is 0, doesn't make sense. So something is definitely wrong with this solution. Of course, it is a solution based on this, but doesn't satisfy the original problem. So that's why you eliminate it. So you still have to mention it, but explain why this is not the final solution. Questions? No? Now, I want you to picture this like you solving a real life situation problem, maybe number of people in a class, and you end up generating a quadratic equation x squared minus 9 equals 0. Of course, when you solve this, you get -3 and 3. You solve the equation, then you tell us, oh, this is not a valid solution, because you're talking about number of people. Number of people cannot be negative. So you explain that in a short sentence, and you say, therefore there must be 3 people. Does it make sense? But at least show the 2 of them, then explain why you are discrediting one of the solution. Okay? Alright. So having said that, I ask you to prove the 10th property. Has anyone been able to try it? You've tried it? Let me see what you did. You want to put it on the board for us? Come on, try it. Let me see what you did. No, 10th property, not the log. The property, x to power log y equals y to power log x. The log, that's what I mean. But let me check this. Okay. Yes, it's as simple as that. String to base n. Perfect. She did the 10th question and she got it right. Perfect. I'm talking about the log, the 10th property I wrote on the board. And I asked you to try it before now. X to power log y equals y to power log x. Has anyone tried it? The reason I'm asking if you have tried it is because I have a question for you to try today. After this, I want you to try this. Show that yes. Interesting, isn't it? And very nice.
What?
Why?
What?
Very nice. Just say it's very nice.
Do we start with that one or do we start with that one?
Which one?
Can we
No, this
start,
is
stop at the
because once we are able to establish this, it might help us here.
finish?
Might.
What if you're not able to establish? Yeah.
Then
We should be able to, so let's start with this.
You're doing
Let's
it
start
well.
with this. Yeah, let's do this together.
Okay, please.
Let's do this together. Has anyone made an attempt? And you got stuck somewhere? Let's hear what
Does
you.
that have something to do with the law where it was like a log b equals b?
A log B.
Wait. No,
You mean law 6?
what's
Law
that?
nine.
10.
I don't know which one is law 6 or whatever. I just
Wait.
put the number.
Yeah. A is a log x base a to the power of log x base a equals x.
Oh, that one. Oh, this. No. Because this has no base. The base is 10. This is being specific. We could say that. If you can make 10 here, then it could come down. But you are not to the x is 10. If x was 10, then your solution is. I thought I saw some, and then I saw myself in the mirror.
Oh.
Okay. What do you think? I gave you a clue last time. Who can remember what I said could be the beginning?
Substitute it, right?
Substitute what?
Like,
Substitute log x or substitute something or something else.
Something for something?
What substitution?
Substitute log y and log x with like p and q. Right?
Okay, I'll start this way. You might think taking log of both sides will work. Yes, it will. But it just justifies that I want us to actually prove they are equal, and you can do it in different ways. One way is this. Let's look at this. Let this x log, let it be maybe a. This is what I asked you to look at last time. And let y raised to power log x be b. So what do we establish? What do we establish to show that this is equal? This is correct. A equals b. So if you are able to get to the point a equals b, then everything is settled. Alright? So now how do we get a equals b? Then we could look at changing it back to log. Okay? So this is index form. So pretend this is p. Okay? So if you have x to the power p equals a, how do you write it as a log?
Log x equals
Log
base x equals
x will have been the base of the log, right? And it will have been the number. So log to base x, a must have been log y. Right? Let's do the same here. Then again, x, y will have been the base. This will have been the number. So log to base b of y is equal to what? Log x. Now remember, our target is to get maybe a is equal to b. You know? So what can we do from here? This is log base x, this is not base x. So it looks like there's a problem. Let's see. Okay.
maybe we can change out to base.
Yeah, we could do that. Yes. Which of them? This?
Yeah.
Okay, rather than base 10, okay, then we have to do the same here. Okay, let's see. Log a over log x equals log y. That's it. Check this also. Log b over log y equals what? Log x. So what do we do now? I'm saying the solution already. Yes?
We can divide. Wait, no.
It's on the right track.
We cancel the logs. I don't
Why
know.
cancel one?
Shh.
Doesn't do anything.
Focus, please. Focus,
Can we
please.
substitute one and two? Yeah.
Oh, I got it. I think I know.
Log x and log y.
Can I?
Yes, who's talking?
So you can multiply log x by log y, and you can multiply yeah, on both
So
sides.
log a equals log x times log y, right? Here also, log b equals log y times log x.
And then there's another law that said that log something on one side equals log something on the other side also equals this is something equals something.
From here. No, it's right, but we don't need that yet. It's right, but we don't need that yet. From here, from these two, what can you conclude?
Log A equals log B.
That's it.
Yeah.
So if log A equals log B, what does that tell us? That's when what you said applies.
A equals B.
And what is A? So put it back. What is A? X log y equals B, y log x. That's it. So nice. Nice.
Can you give us time to copy it now?
Yeah, of course. There is a way that somebody might think, but for me, I don't think that is rigorous enough.
There's another way of doing this.
Yeah, just take the log from here. Take the log of both sides from here. But that's not convincing enough for me. I think you are just testing if you are not going to run into contradiction. If you take the log of both sides, what do you get? Log x, log like that, right? Log y, log x, right? Then the power come backward. So you have log y times log x equals log x times log y. And there is no contradiction. This makes sense. So to me, applying log on both sides is just testing if you are going to run into contradiction.
What do you
Not
do?
establishing
Take log on
the
both sides.
stuff. Huh?
Put log on both
Put
sides.
log on both sides of this equation.
Okay.
Without the log, this is what you have. Without the log, this is what you
And
have.
then you know what to do with the powers, right? If there's
No.
No, you put the power. Yeah, you put power.
If you could calm down, you will understand what we're saying here. Put log here. Put log here.
Oh, because
And that's that.
yeah.
And by the law, this comes that way. So that's why I said you need to calm down. To calm down, you can see clearly.
Why would we need to do all that if we can just do that?
That's what I'm saying. I will accept it as a solution. Because to me, you're just trying to establish, oh, 8 is equal to 8, so everything is okay from the beginning. So this is a way of, if you had gotten 8 is equal to 7, no, this is not possible. It means the beginning is wrong. But you are trying to check if you can run into contradiction. And when you are trying to use proof by contradiction, we are going to learn proof is the last thing in the first topic. If you are proving by contradiction, you already know it is wrong, or you are assuming something and you run into a problem. For example, I say, suppose x is 8. At the end of the day, you end up getting 6 is equal to 7. Then x is definitely not 8. But in this case, you are proving something and you don't run into contradiction. Then you want to use that to justify that this must be right. I knew it was right, that's why I asked you to show it, not test it. To me, I see this as testing it if it is right. But this is showing it, indeed.
But I'm confused. They're both kind of doing the same thing. Why is this one better than that one?
Because you assume whatever it is on the left is A, you call it something else entirely. On this, you call it something else entirely. Then you want to show that if indeed this is true, because I call them different things, these so-called different things must actually be the same. I don't know if you're getting my point. Log A equals log B. We call them different things. A and B, we assume they are different at first. But we realize that their logarithms are the same. Then the so-called different things actually is the same thing. That is what it means. So here, you choose a different things for this. You choose a different things for that. You separated the equality. But here, you're already working that, oh, they must be equal, so take their log.
Okay, good now.
But here, you assume, okay, there are different things, so I'm going to call you P, I'm going to call you Q. But if eventually the P and the Q later meet again, then definitely they are bound to be the same.
So the difference is, in the first one, you're separating them, and the second one,
And establishing that it is true.
the second one,
But
you're
here-
saying it's equal.
You already assume it is equal, and you're just trying to show that there is no contradiction.
Okay.
Then what if we have like, just like general, not this, what if we have like, you have to prove A equals B? Can we do like A minus A equals 0?
If you want to prove A equals to B, if you're able to show that A minus B equals 0, yeah, that would be acceptable. But you don't start from your A equals B. Okay, for example, I ask you, show that A is equal to